Hello there, Nareg is here, and today I'm gonna talk about the sign of scalar product or dot product. So previously I had done a certain video where I was talking about the scalar product only, three definitions in order to calculate the scalar product. But in this video, I'm gonna talk about how to find out about the sign of a certain scalar product. I'm gonna remind you that we have the scalar product written as, let's say we have the scalar product is between these two vectors AB, scalar AC. There are three main different cases that you can have between two vectors. So the first one is when you have, let's say this is AB and this is AC. The second case is when you have AB and AC, and the third case is when you have AB with AC. As you can see, I'm changing the angle, so I'm going to talk about the geometric angle. This is the angle alpha. As you can see, alpha is acute. In the second case, alpha is a right angle, so alpha is a right angle. And the third case is alpha, which is obtuse. What happens with the scalar product when alpha changes its value? Whenever it's acute, cosine of an acute angle is positive. So let's go and use the definition. We know that AB scalar AC is actually equal to AB times AC times cosine alpha. The same thing goes here also, AB times AC times cosine alpha. And for the third case also, it's AB times AC times cosine alpha. Now, for the first one where alpha is acute, cosine is positive. The segments AB and AC in the three cases are positive, so the scalar product will change its value regarding the cosine of your angle. So the first case, cosine alpha is positive because the angle is acute, so this will be positive. The second case, alpha is a right angle, so cosine of 90 degrees is 0. So this scalar product will be equal to 0. As for the third case, you will have cosine of alpha for obtuse angle, it will be negative. Obtuse angle is related to the second quadrant in the trigonometric circle. So in the second quadrant, cosine is negative. So automatically you will have this scalar product as a negative value. This was the definition where we used AB times AC times cosine alpha. Of course, in case I was willing to use the projection of, let's say I'm going to do the projection of C over the vector AB, and I'm going to call it this H. The projection of C over AB, and this is H. The projection of C over the part AB, and this is H. I can say that it's also AB in algebraic measure times AH in algebraic measure. Similarly here, it's AB in algebraic measure times AH in algebraic measure. And the third one is also the same. Whenever we're talking about algebraic measure, it's very important to check the orientation or the direction of these two segments. Let's say the first case, AB and AH have the same orientation, both of them are towards the right, so this will be positive. AB and AH, as you can see, A and H are co-founded, so AH is equal to 0, so this scalar product or this product will be equal to 0. And the third case, you have AB towards right and AH towards left. Both of them have different direction or different orientation, so it will be negative in this case, the scalar product. So this was the part where we need to find out about the sign of a scalar product by checking the angle, or checking if the new segment, which is a certain projection of that point C over the vector AB or the segment AB, we will have AB times AH. We have to check if AB and AH are both in the same orientation or opposite orientation. As for the scalar product, which is the analytical form x times x prime plus y times y prime, in that case it's much more easier. You simply have to use the components and you will be able to find out its value. Of course, you can also do the same thing by checking over your coordinate plane. Check if the two vectors have an acute angle, an obtuse angle or right angle, so it will be the same thing. Alright, I can simply remind you that the formula of the analytical form is x prime plus y prime. Alright, so this was the sign of a scalar product. Now, there is an important part which is also linked to the sign of the scalar product, is when we have the scalar product which is 0. And this is related to orthogonal vectors. So, orthogonal vectors. Now, in this case, whenever you have u scalar v is equal to 0, it directly implies that you have u orthogonal to v. Or if you have u orthogonal to v, it means that the scalar product is equal to 0. Now, there are some important cases which we should pay attention to mainly. If we have u is equal to 0, and I want to calculate u scalar v, it will be 0. Or if v is equal to 0, again, u scalar v is equal to 0. But I cannot deduce that if u scalar v is equal to 0, it does not imply that u is equal to 0 or v is equal to 0. You have to pay attention to this part. So u scalar v is equal to 0. It does not imply that u is equal to 0 or v is equal to. It could be, but it's not important that u is equal to 0 or v is equal to 0. What I can deduce that u scalar v is equal to 0, it means that u and v are orthogonal. Similarly, you can use the formula of u scalar v. Whenever you are using the analytical form, you can find out that x prime plus y prime is equal to 0. Again, it means that these two vectors are orthogonal. I'm going to take a small example. Let's say we have u with its components 3, 4, and v with its components -8, 6. As you can see, both vectors are different than 0, since they have a certain component related to the abscissa and the ordinate. So I'm going to calculate u scalar v by using, of course, the analytical form. So it's x prime plus y prime. So it's 3 times -8 plus 4 times 6. It will be -24 plus 24. So it will be 0. As you can see, u scalar v is equal to 0. It implies that u is orthogonal to v. Alright, this was a certain remark related to the sign of scalar product. That's all for this video. I hope it was helpful, and I will ask you to subscribe to my channel, because you'll be notified whenever I upload new videos, new material, and I can also share with you my Instagram, Facebook account. You can contact me directly, or you can simply leave a comment below. I hope it was helpful, and see you.